I'm going to take you through this review so that you have something to look at for this weekend if you get stuck. But checkpoint A part 2 will happen on Monday regardless. So we're going to come in. Hopefully you will have used this to help fill in yours and understand what you're doing. But we'll take that checkpoint on Monday. And then we'll have a day and then we'll retake part 1 or part 2 or both. So number 1 is long division. Circle your remainder in your work so you don't have to worry about typing it into the box. Long division can be kind of gross, so you just have to make sure you stay organized some way, shape, or form. So how we do this is we put our 3x plus 1 on the outside. Set up your long division, 9x cubed minus 18x squared minus x plus 2. And you have to make sure you have one of each exponent, which we do here, so we don't have to put any zeros. But say we were missing x squared, we'd have to put a 0 there. Just a reminder. But now it's all about 3x and 9x cubed. How do you make 3x become 9x cubed? Well, you would multiply by 3x squared. Because now the next step is where this kind of helps, because we have to distribute. So we have to do 3x times 3x squared, which is 9x cubed. These should match, that's the whole point. And then 1 times 3x squared is plus 3x squared. Now we're at the point where we have to subtract. So I'm going to make that really big so you remember that 9 minus 9 is gone. Negative 18 minus 3 is negative 21. Use a calculator if you have to so that you don't make silly subtraction errors. So it's negative 18 minus positive 3 is negative 21x squared. Drop your negative 1x. And now we're right back at the start where we're looking at 3x and negative 21x squared. How do I make 3x become negative 21x squared? Is multiplying by negative 7x. Do your distribution. 3x times negative 7x is negative 21x squared. We want those to match once again. 1 times negative 7 is negative 7x. Now we're at that subtraction part. Be careful here with the negatives. So when I subtract, those are gone. Negative 1 minus negative 7 looks like this. I'm just going to put it off to the side. Okay, so you got a double negative situation going here, so that's actually 6x. Then we drop our 2, and we do that whole process one more time. So we have to think about how does 3x become 6x? Well, I would just have to multiply 3x by 2, a positive 2, so that's my last part. Then you do your distribution. So 3x times 2 is 6x, and then 1 times 2 is 2. And then we just kind of take a look at if we have a remainder or not. I'm going to show you here in a different color when I subtract here. Those are the same, so they're gone, and 2 minus 2, so my remainder here is 0. So just make note that that's your remainder. Sometimes that's a different number. And this right here is your solution. So 3x squared minus 7x plus 2. Okay? Number 2. We have x cubed minus 13x minus 12 divided by x minus 4, but it says use synthetic. So now I'm going to take you through synthetic division. Synthetic division is the one where you set up the box and we use all coefficients. So when we set up the box, we have to remember that this is the factor. X minus 4 is the factor. So you have to use the opposite sign. In synthetic, that's the only time you do this. So 4 is what we put in the box, even though the factor was x minus 4. Now be careful with coefficients here, because I'm just going to jot this down and then I'll erase it. We are missing some here. We have x cubed, we have x, and we have like a no x. We're missing x squared. So when I'm filling in my coefficients, I have the 1 for x cubed, but then I have to put a 0 in there for x squared, and then your negative 13x, and then your negative 12. If you don't put that 0, you will get this wrong, okay? Because there's no x squared, we have to put a 0 in for it. But now we're going to do our synthetic, and remember, synthetic is addition. So they have different methods, so you just have to make sure you're paying attention. Drop your 1. That would just be 1. And then you multiply. 4 times 1 is 4. Now we add 0 plus 4 is 4. Now we multiply again. 4 times 4 is 16. And then we add negative 3 times, or plus 16 is Negative 13 plus 16 is positive 3. And multiply one more time, that's a 12. Draw your line because this is where our remainder is going to go. Negative 12 plus 12 is 0. So this right here is my remainder. And then you just have to remember that from your original problem to your answer, it drops a degree. So we were at x cubed. So this one right here is 1x squared. This one right here will be a plus 4x. It just goes down each exponent. And then this becomes just your plus 3 at the back. Okay, and remember for go formative, and we have a remainder of 0. Remember for go formative, don't type the 1 if you want that automatic green bubble. I think I put both, but just in case, just type that. Okay, no remainder. So then it actually leads directly into our next question. From number 2, is x minus 4 a factor of the polynomial? Is it a solution? So we have to explain that. Since we had a remainder of 0, yes, this is, okay? It is a solution because, I spelled the pads wrong, the remainder was 0. If you ever get a remainder that is not 0, then that factor, that number you use for synthetic, is not a factor if that remainder is not 0. Because a remainder of 0 means nothing's left over, so that divided perfectly. If you were left over with 4, that means you have left over 4, so that number did not divide evenly. So that's how you answer that question there. Number 4. Write the following polynomial in factored form from its factor of x minus 2. So when I give you a factor, you have to use it. And we always use synthetic just because that's the quicker one. So you're going to take your factor of x minus 2, and I'm putting it into synthetic division, but I use the opposite sign, okay? And then I use all my coefficients of my problem. So 1, negative 8. There's no holes here. We have one of each. This is going to help us just break it down to make it an x squared to see if we could factor this. So I'm going to drop my 1. 1 times 2 is 2. Negative 8 plus 2 is negative 6. 2 times negative 6 is negative 12. 17 plus negative 12 is 5. And then here's my remainder spot. 2 times 5 is 10, so I have a remainder of 0. Remember, whenever we're doing this process, you want to have a remainder of 0 because I want to just have my factored form. So my new coefficients. I don't want to have a leftover, so this is good. So let me write what I have so far. I have x minus 2 as part of my factored form. Because of this, I'm just going to draw an arrow. You have to remember that that's part of your answer. But then I also have these coefficients, which become my new quadratic because I drop a degree. So the 1 becomes an x squared, the negative 6 becomes negative 6x, and the 5 becomes 5 at the back, okay? So the 2 drops down to become a factor, and these become my quadratic. But I'm just not completely done yet with this one. So I did my synthetic, I made it a quadratic, but I need to check to see if I can factor this new quadratic. So I'm just going to write that really quick. We are factoring this. So multiply to 5, add to negative 6. So I'm going to write kind of what we have still. My x minus 2 drops down. That is part of my factored form. You cannot forget that guy. But then let's factor this new one. So two numbers that would multiply to 5 and add to negative 6 would be 2 and 3. But we got to make them both. No, they're not 2 and 3. They're 5 and 1. Because 2 times 3 is an even 5. Wow, nice. So 1 and 5, but make them both negative. Because now negative 1 plus negative 5 is negative 6. And negative 1 times negative 5 is positive 5. So x minus 1 and x minus 5. This is factored form. I'm not asking you to solve it, so I'm just asking for what all of this becomes in factored form. If I asked to solve, I would ask you to take the opposite signs and actually solve them, but not for this one. Okay, so synthetic to make it a quadratic, this part, and then factor that quadratic. Or if I asked you to solve, you could put it into quadratic formula like we did yesterday on the checkpoint, but not for this one. Okay? So there's that one. We're getting there. Number 5 is find all the possible rational roots. Notice how I'm not asking you what they are. I'm just asking you for the possibilities. So this is the P and Q thing from the very last day. Okay? Your P is always that last number, so negative 27, but I don't care about the negative, so I'm just showing you that. I just care that the number is 27. And then the q is the one in front of the x cubed, which is just 1, which in this case is really, really nice for us. So we have to list out all of the factors of each. Q obviously is just plus or minus 1. But 27 could be plus or minus 1, plus or minus 27, because 1 times 27, or plus or minus 3, or plus or minus 9, because 3 times 9. So these are nice numbers because there's not a lot of options, and all you have to do are the different options of P divided by Q, okay? So you just go through, which these are nice because the Q is 1, so literally all of them are just going to be 1 over 1, 3 over 1, 9 over 1, so I'm just going to draw arrows. 9 over 1, and 27 over 1. So no math, really not a lot of thinking. You just have to remember to do the P and the Q. So plus or minus 1, comma, plus or minus 3, comma. Notice how I'm not doing any spaces. Plus or minus 9, comma, plus or minus 27, and we're done. So P over Q, all of the combinations. Tomorrow's or Monday's might not be this nice. So remember the process. It's all P over Q. Number 6, if a polynomial has the following roots, find 2 additional roots. So the 2 additional roots come from the i's and the radicals. We can have conjugates of those, not of the negative 5. So a review on this one. Negative 5 does not automatically have an opposite of 5, but 4 plus 3i has 4 minus 3i. Forgot an I, okay? So this has an opposite, and then the radical 17 also has a conjugate of negative radical 17. Notice how I didn't do any spaces. But the 5 does not automatically become an answer because of the negative 5. It's only i's and radicals. So that one is for number 6. And then we have 2 more. We have to put it all the way into standard form. So these are the ones where we do have to we got to do some work here. So if I write a second polynomial in standard form with this root, if I have 1 minus 3i, you have to know that you also have 1 plus 3i. You just have to know that, okay? So then my factors, you have to put it into factored form first. I'm going to write that here. This is the gross, like, triple FOIL. So one of your factors is going to be x minus 1 plus 3i. It's just the opposite of this first one. And then the other one is x minus 1 minus 3i. So it's the opposite of the second one. So notice the only sign that's changing with your factors is the one that's attached to the 3i. So now we're going to go through that triple FOIL. I'm going to do it in different colors so you can see. Personally, I like doing all of my first. So x times x is x squared. X times negative 1 is negative 1x. X times negative 3i is negative 3ix. Remember, those gross ones will cancel out, so don't get flustered with that. Then I'm on to my negative 1, so negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. Negative 1 times negative 3i is positive 3i. And then I'm on to my last one. And if I'm going too fast, you can slow down the video and rewatch it, okay? Last one is the 3i's. So 3i times x is plus 3ix. 3i times negative 1 is negative 3i. And then the last is 3i times negative 3i is negative 9i squared. And that one's a special one that actually really helps us here. So we have to look for now things that will cancel. So 3ix and positive 3ix. Positive 3i and negative 3i are gone. And let's just clean up the rest. So I'm going to notice here that I have 2 like terms. So I'm going to combine those. I'm going to go x squared minus 2x now, because those 2 become 2x. And then I'm going to write this so we can see what happens. Plus 1 minus 9i squared. These 2 will become something. We just have to play with the I squared. And you could have done this in one step, but the I squared becomes a negative 1. So what I end up here with is, just to show you this middle step, x squared minus 2x plus 1 minus 9 times negative 1. And negative 9 times negative 1 is positive 9. So I end up with x squared minus 2x plus 10 for my final answer, because the 1, this would become, just to show you one more time, plus and plus. 9 times positive 1 is positive 9. 1 plus 9 is 10. Okay, so gross triple FOIL, but if you remember how to set up your factored form, that's getting you halfway there, and you just have to play with that FOIL. Last one here. This is the easier of these two types of problems. The FOIL itself is. So if I have the solutions of 2 and radical 5, you have to know, I'm not going to tell you this, you have to know that one of these has an opposite factor, and it's the radical 5. You can have a negative radical 5, not the 2, okay? First thing you have to do is write it into factored form, so I'm going to just show you with arrows that this one's going to become x minus 2, because factored form is the opposite sign. The next one is going to become x minus radical 5, because it just becomes the opposite sign. And then the last one is x plus radical 5. If you forget about that, that first step we talked about, you won't have everything you need. So make sure you remember that part. This just takes 2 rounds of FOIL. So to show you the first one, I'm going to do it in blue. I'm going to do the radical 5 ones. So firsts is x squared. Outers is plus radical 5x. Inner negative radical 5x. And lasts negative radical, make sure you multiply 25. But I'm going to clean this up. I'm going to show you, though, that we do have to drop our x minus 2 down each time. It just follows us until the end. And then these cancel. And then this becomes, this right here, just becomes regular 5. Okay, so what I have here is x squared minus 5 and my x minus 2. So that the radical ones can't, like, things cancel because of the conjugate idea, the radical 5 and negative radical 5. So that's going to happen. Now we have to do one more set of FOIL, but it's not a 3 by 3. It's a nice just 2 by 2 here. We'll do it in this color to get our final answer. First, x times x squared is x cubed. Outers, x times negative 5 is negative 5x. Inner is negative 2x squared. And lasts is positive 10. But make sure you put this in the right order. This is not in the right order. These two have to switch because the x squared has to come first. So my final answer is x to the third minus 2x squared minus 5x plus 10. Okay, and we're done. So that is the review. Again, if things were too fast, go back, rewatch it, slow it down. Don't just like try to breeze through it, or else you're going to have the work tomorrow on Monday, but you will not have any idea how to finish it. So, or like how to do it with new numbers. So make sure you do use this and then get that assignment done for you. You'll have all class today. So, yeah, do that. And I will see you on Monday for Checkpoint A, Part 2. Have a good one, guys.